Question 5 is coming from geometric progressions. The first, second, and third terms of a GP are 2p plus 6, 5p, and then 8p plus 2 respectively. Part A, find the possible values of the constant p. Now, we know that the first term is given by a, the second term is ar, the third term is ar squared. If I get the second term and I divide by the first term, you can see that a disappears, then we get the r. Similarly, if you get ar squared, then divide by ar, you will still remain with r. So that means for us to get to the common ratio, you get the preceding term divide by the preceding term. Okay, so I can say common ratio r is equal to the second term, okay, divide by the first term, which is the same as saying the third term, then divide by the second term. So what we have as the second term is 5p, then the first term is 2p plus 6, and this one is equal to the third term is 8p plus 2. Then we divide by the second term, which is 5p. Now when we cross multiply, this one will give us 25p squared, which is equal to, then this 8p plus 2 has to multiply with 2p plus 6. So 25p squared will be equal to 8p times 2p, that will be 16p squared, and then 8p times 6, that will be 48p, right? 48p, and then 2 times 2p, that will be 4p, then 2 times 6, that will give us 12. So putting everything this side to form one quadratic equation, 25 minus 16, I think that will give us 9. So we shall have 9p squared, and then this one is 52p. So when it crosses, it becomes a minus. So minus 52p, and then minus 12, which is equal to 0. Now, this one is a quadratic equation in P. I can use the calculator to simplify it. I'll go to mod, then equation is 5, and then 3, that is the quadratic. We shall have 9 here, then minus 52, and then the other one is negative 12. So this one will give us a 6, and then negative 2 over 9. So I will say P, I'll leave some space here, then I write here P is equal to negative 2 over 9, and also the other one, P is equal to 6. But then we have to show the examiner that we have solved the equation. So cross multiply, give us the factor from which these roots are coming. Okay, give us those two factors. So when I cross multiply, we shall have 9p. Then when this one crosses, it becomes a plus. So we shall have 9p, then plus 2. Okay, and then bring this one here, it becomes a minus. So we shall have p minus 6 is equal to 0. By doing that, you would have cheated the examiner. You see? So these are the two possible values of p, negative 2 over 9 and then 6. Okay, then part B, one of the values of p found in A is a negative fraction, which is negative 2 over 9. You see that? Use this value of p to find the sum to infinity. Now, from here, you know sum to infinity is equal to a over 1 minus r. So since p is equal to negative 2 over 9, then we need to find the first term. So the first term from here is 2p plus 6. So we have 2, then the p is negative 2 over 9, and then plus 6. So this will be 9 times the 6, that will be 54. Yes, then minus the 4, that will be 50. So we shall get 50 over 9. Okay, and then from there, the common ratio r, I can use any of these two expressions, either this one or this one here. Okay, so suppose I take the first one, 5p. So we have 5, then p, which is negative 2 over 9. Then out of the other one is, actually that is the second term, right? This is the second term. Now the first term, I've already gotten it. Not so. The first term, I've already gotten it here, so I don't need to waste time. I can just put this one over 9. So this one is actually the same as negative 10 over 9, then times the reciprocal of this one here. So it will be 9 over 50. Now this 10 will go in here. How many times? Those are 5. So this one disappears. Isn't that negative 1 over 5? That is it. So we get negative 1 over 5. Now we can substitute in the expression for the sum to infinity, which is a out of 1 minus r. So our a is 50 over 9, then divide by 1, minus minus, that will be a plus, right? So altogether, what do we get here as our answer? We have 50 over 9, then down here we have 1 plus 1 over 5. We get 125 over 27, 125 over 27. I will leave it exact, or if you want, you can put it to 3 significant figures.